Welcome to Vodcast 2.2, Multiplying Matrices. We're only going to be covering two things in this unit, scalar multiplication of matrices and matrix multiplication. Scalar multiplication is pretty easy. Scalar is just a fancy word for the word number. So we can multiply matrices by pretty much any number, 2, 4, 1/2. Let's look at an example. So if we wanted to multiply matrix A, as shown here, let's say by the number 2. First thing we have to do is set up the equation, which would look something like this. 2 in front of the matrix. Next thing we're going to do is multiply each entry by 2, as shown here. The resulting matrix looks like this. We have to remember that each entry retains its position after being multiplied by 2. So 0 times 2 equals 0. It retains the A11 position as it had before. The A12 position, 5 times 2, becomes 10, but it still retains its position within the matrix. As you can see, there's a 2 by 2 matrix here, and the resulting matrix is a 2 by 2. So what if we wanted to perform multiple operations with the matrices? As seen here, we want to do 3A subtracted by B. So here's matrix A, and here's matrix B. First thing we need to do is set up the equation. So we need to be diligent about, this is 3A, we're multiplying A, matrix A by 3, so we need to make sure we plug in the right matrix here. This is matrix A, and it matches with our matrix A up here. Subtracted by B, so these two match right here, so we know that we set up the equation correctly. The first thing we're going to do is multiply, because we still have to follow order of operations, and multiplication is before subtraction. So here, we've multiplied the 3 throughout this entire matrix. So we get this new resulting matrix, and we still are subtracting B, so we're going to leave that at the end. The last thing we have to do is subtract B from 3 times A, so we get this resulting matrix. Notice how these two matrices are 2 by 2s, and the resulting matrix is a 2 by 2. The same rules from the last unit apply. If these matrices did not have the same dimensions, then we could not perform the subtraction. Okay, I'd like you to pause here and try these scalar multiplication using matrix A and matrix B. Okay, multiplying two matrices is a little bit more difficult, so I need you to pay close attention and take very detailed notes. Let's get started. Let's say we want to multiply a matrix A by matrix B. The first thing we need to do is identify the dimensions of each of the matrices. Matrix A is a 3 by 2, and matrix B is a 2 by 2. We wrote them in this order because it's A times B. What we're looking for here is for the columns of matrix A to match the rows of matrix B, which they do. So we know that we're good to go for the multiplication. We can multiply these two matrices by each other. The cool thing about this is the resulting matrix of the multiplication, after we're done multiplying, is going to be a 3 by 2, which is our remaining two numbers. So the dimensions of the matrices tell us two things. First, they tell us whether we can multiply the matrices together, and then it tells us the dimensions of our new matrix after multiplication. So let's look if we wanted to do B times A, so matrix B times matrix A. First, we're going to look at the dimensions. Since we're doing B times A, we're going to write the dimensions of matrix B first. Then we're going to write the dimensions of matrix A. So 2 by 2 and 3 by 2. Notice that the columns of matrix B do not match the rows of matrix A. So therefore we know that we cannot perform this multiplication problem. Make sure you check whether you can perform the multiplication problem before you actually do it. So let's go back to the multiplication problem we can actually perform. A times B. This is a good setup. We have A here and B here. Remember we said that A was a 3 by 2, as shown here, and B is a 2 by 2, as shown here. Our resulting matrix is a 3 by 2, which is shown here. So follow along very closely. Don't be afraid to rewind or pause as I go through the explanation of how to multiply. What we're going to do is we are going to form intersecting columns and rows. Let's start with this column and this row. they intersect right here. So we're going to be multiplying to find this entry right here. What we're going to do is we're going to take the first number in this row times by the first number in this column, as seen here, 1 times 1. Then we're going to take the second number in this row times the second number in this column, which is 4 times 4. We're going to add them together, and we're going to get our resulting entry, which is 17, which we'll put in right here, which is our solution matrix. All right. Next, what we're going to do is we are going to find that this column also intersects with this row right here. So that's going to help us find this entry that goes right here. We're going to do the same thing. First number or entry in this row times or multiplied by the first entry in this column, 1 times 2, and then the second entry in this row times the second entry in this column, 5 times 4. 2 plus 20 is going to be 22, so 22 becomes this entry right here. This column also intersects with this last row, so we're going to perform the operations using that last row as well. So we have our first number in this row times again, multiplied again by 1, which is the first entry in this column, and then the second entry in this row multiplied by the second entry in this column. 1 times 3 plus 4 times 6 is going to be 27, is our last entry in this column. So we still have a whole column to go, but this is how we figure out the multiplication of the first column in our solution matrix. Let's look at the second column. Just as a little reminder, this is matrix A and this is matrix B. We have our first column filled in because it's already solved. So this column also intersects with all of the rows. So we have this column and this row intersecting to form this entry. Let's take a look at it. 6 is the first one in this column, times by 1, which is the first one in this row. 2 is the second one in this column, times by the second one in this row, which is 4. Our resulting entry is 14. This column also intersects the second row to form this entry. Here's the solution for this entry. Make sure you can follow along and see where we got these numbers. So we have 22. I'm going to let you try to do the last one by yourself. If you got 30, then you are correct. Again, you're going to do the first in this row times the first in this column, 3 times 6, added to the second entry in this row times the second entry in this column, which is going to be 2 times 6, so 18 plus 12 is 30. And that's how we multiply matrices. Alright, so what if we tried B times A? We already know it won't work because the dimensions don't match up correctly, but let's just say we tried to do it. Alright, so by our multiplication rules, this row intersects this column right here at this entry. We know that this is a 2 by 2 matrix is going to be the result because B is a 2 by 2 and A is a 3 by 2. Again, using our rules, we know that we cannot multiply these together, but I'm just doing a little demonstration to show why we cannot multiply them. But if we could, the resulting matrix would be a 2 by 2, because those are the remaining numbers. So again, this is matrix B, and this is matrix A. So this row and this column intersect to form this entry. So we're going to do first in this row times first in this column, plus second in the row by second in this column, but then as you'll notice, this 3 has no one to multiply by. That's another reason we cannot perform this multiplication. So let's do a little bit of a comparison. If we have matrix A and matrix B, they're both 2 by 2 matrices. And we know that since these two numbers match, we can perform this operation, and we know that it's going to be a 2 by 2 matrix. So we have it over here. We have matrix A and matrix B, and we have our 2 by 2 matrix. So we're going to do this column intersects this row to form this entry. Here's the addition, so we have 31. We're going to do this column, or this row, intersects this column here, which is shown here. This column also intersects these two rows, and these are the results. So, as we see, that is the resulting matrix. Let's say we wanted to multiply B times A. We know that we can do it because they're still 2 by 2 matrices, the numbers match up, and our resulting matrix is also going to be a 2 by 2. So as you can see, we've switched positions. This is now matrix B, and this is matrix A. So notice that these are flip-flopped in their position depending on whether B or A was listed first in the multiplication. So go ahead and try to perform the operations. And these are the results, and this is the resulting matrix. Notice that even though we are multiplying the same matrices together, because we've switched the position, we get a different matrix. Okay? So just be careful about making sure you have the right matrix in the right position in order to get the right solution matrix. This might be a good slide to review if you want to practice multiplying matrices and seeing the work out. So you could go through this slide and multiply these matrices on your own to see if you get the same results. So I'd like you to pause here and try these matrix multiplication problems on your own.